Hey guys, welcome back. Today we'll take a quick look at the assembly of the electronics and the code for the DIY gas sensor for emergency responders. So if you didn't already see the previous video, I'll link it down below. It shows you this assembly inside this ball that we can chuck into a dangerous area and remotely monitor our gas readings via the MQ2 sensor here. I've done a lot of testing on this. Sorry guys, this is a really ugly prototype because I already had this assembled for another use. I'll make a final version where we don't have this daughter board and we do a better job with the transmitter. The long and the short of it is we're using an Arduino Nano, a 433 megahertz amplitude shift keyed transmitter, a power supply, in this case I'm using the Adafruit Power Boost 500, and the MQ2 gas sensor. Quite simply, we're taking the measurements from the MQ2 and broadcasting them out via voice, so we can receive them with any handy-talkie like this.
LPG, 0 CO, 0 smoke, 0 brake.
Works with any radio that's capable of receiving on the 433 area, 70 centimeter band. Works perfect. I'm really happy with it. This is a heated gas sensor, so this thing draws quite a little bit. It has a heated element in here, and we'll show you that. So here with an infrared camera, you can actually pick up the heat coming off this. Guys, I don't really recommend that you run this off the Arduino 5 volt, but for this prototype it worked just fine, and I have yet to have a problem. There's the Arduino running happily, and transmitter no heat there, and the power boost minimal at best. But yeah, that's the long and the short of it. Let's have a look at this thing. So I'll throw a schematic overlay. You can find this on the Hackaday site as well, Hackaday.io. I'll post that down below. Guys, if you like this project, please consider going over to that link and give it a skull, which is basically a thumbs up like YouTube. Using that schematic, you can assemble yours no problem. Let's have a look and see what we get out of it via code. Let's go ahead and plug this into the serial port of the PC. See if we can get the serial monitor fired up here. That will reset the module. And we should get calibrating. We do. I'll let this calibrate and I'll cut back in a moment. Calibration is done. And we're back reading values. So I've printed this to serial in the codes for troubleshooting. It makes things so much easier. Let's turn off the external radio here. We'll go ahead and let's hit it with a little bit of gas. And there we go. We've got our readings. We picked it up on the LPG, no problem. Worked perfect. So let's have a quick look through the code here. I won't spend a lot of time on this. You'll be able to download this code and check it out yourself. I put lots of comments in. You'll see at the beginning, you have a link to the Hackaday site, to my channel, some information on what IDE to use. Make sure that you're using the same IDE as me if you run into errors. And some summary of the release notes from the different versions I've made. I've gone up, this is version 5 currently, there may be more. You need the talkie.h library, and here is the information from the original maker of this. Thank you very much to Peter Knight for making this available. We define what we need to say, so we need a bunch of numbers here. We need to be able to speak these numbers, and these are the values that the library is going to use. I added some more that I use, alert and smoke and calibrate and start, and there's a couple commented out. You can remove those if you really wanted to. This is where in the void say number, this is all the code related to converting the value and being able to say it in voice. It's pretty self-explanatory once you get into it. Go ahead and read through at your leisure. The MQ2 code was ported in here as well, and here's the links to the original designers of this code, because I did not make it. Sandbox Electronics in 2011 put this together. Very cool. This is where we set up the curves for the smoke CO and liquefied petroleum gas, as well as the resistance value. In the start, you can see I just have it say start 3 times and calibrate to notify the user. This is where you're going to add, or I will add some code in the future to force a major delay to allow the sensor to warm up. Serial print calibrating, not much to it there. Calibration is done, kick out the values, and let the user know via the radio that we are ready. In the loop, there's not much to it. We're doing serial print the LPG value, say LPG, get the LPG value, and you'll see that down below how we do that on the curve, and go through, serial print it out. Not much to it, guys. Really, really straightforward. It looks more complicated than it is. We repeat that with the CO and the smoke. Nothing to it. In here is the original MQ2 code where we actually do the resistance calculation. This is where we read the pin to get our actual values from the sensor and convert those over. And here you go. Here's where we return the values. Not much to it, guys. Really, really straightforward. Won't spend any more time on the code. That is all there is to it. So guys, as I mentioned, I'll go ahead and put this back together in a better package, get rid of this daughter board, put it back in the ball so we can go do some live tests. I've already done range tests on this transmitter. Works great so far, so I'd love to do some live tests in a building, in a smoke environment. This sensor is definitely not the best. We need to go to a commercial grade unit, but for now, for the proof of concept, hey, it's working fine, let's stick with it. Guys, make sure you go over and click the skull button on the Hackaday site. It really helps this project. Click the thumbs up down below if you like these videos. It really helps this channel. Good luck in all your ventures. I hope you build one of these. Thanks for watching.